So I hate working from home. So I get an office, and I'm super excited about the office, and I move everything into the office. And now I'm working from home. What's up, you guys? My name is the Cherno. Welcome back to the Hazel engine, or the game engine series, as it's also known. This is the first episode of 2020, and it's halfway through March. And I'm sorry about that, but there's just been so much stuff going on. I just haven't had the chance to sit down and do this, but now it is time. And you know, all jokes aside, this light is so bright. Jokes aside, it isn't all that bad being at home. In fact, I'm cooking a fantastic Indian curry that's just gonna take hours, but I can do that because I'm at home. Been really digging Indian food lately. Anyway, let's talk about Hazel. Let's talk about the state of this whole game engine. And I've got it in front of me here, so we're gonna kind of have a chill episode today. It's the first one of 2020. I just wanna talk a little bit about what it is we're gonna do this year. I'm gonna set some goals this year. And by goals, I mean things that I can actually say, this will be done by the end of the year, or at least that's the goal. I mean, hopefully we're gonna meet these goals, but the point is we're gonna sit down right now, you and me, and we're gonna talk about what is gonna come in Hazel. And in fact, we might even tweak a few things that I'm already disliking just looking through this code. So what exactly is the plan for 2020? So for those of you who have been following the series for some time, you know there's kind of two different branches of the Hazel engine, and I'm developing kind of this public branch, which is like everything on screen, step by step, kind of once weekly episodes. And like the benefit there obviously is that everything I do ever is shown here. I mean, there are some kind of pull requests that do go in to the GitHub repository and I don't show them on screen, but any code that I type, you see. It's completely all recorded on video. But that obviously has its problems. The biggest of which is that's very slow. It's very slow for me to work like that. It's not really how a software engineer writes a game engine. It's just takes too much time. So what I do is I also develop a version of Hazel in my spare time, and I call that the Hazel development branch. Now this branch is completely available to patrons who help support the show. Patreon.com/thecherno is of course the best way to help support this whole series and this whole engine and my whole life. But the point is that I'm developing this dev branch of Hazel in my time. It's the code that I write for Hazel when I sit down and want to write code, which to be honest, it's been a very long time since I've had the opportunity to do so, but I am definitely gonna do more of that this year. That's one of my goals for the year, is to spend more time actually programming. That dev branch has like 3D rendering and all of that. It's got physically based rendering, it's got like a 3D scene, it's got like a kind of editor style I'm GUI like UI where you can load any model, you can load any texture, and you can kind of play around with all these different parameters. It's a much more mature version of the Hazel engine. And that is in fact where we're heading with this. However, I do want to clear a few things up. Firstly, we are heading towards that. Like this engine will of course be 3D, and by this engine I mean the public kind of version. The game engine series version of Hazel will obviously be 3D. That's where we're heading. Hazel Dev is already 3D and has been this whole time, but we have different goals than the dev branch. That's why there's two different branches. If they were like the same, then there would be no point of even having two different branches. But the fact is we have these two different versions of Hazel, and what we're developing publicly is Hazel 2D, and then Hazel 3D is in that dev branch. That's kind of cool because it lets me develop these kind of two different versions of the engine. If I get bored doing like 3D scenes and stuff like that and I want to do maybe something 2D or something else, I can kind of focus my attention on the game engine series and develop that branch further. But it's important to understand that at the end of the day, it is still all one engine. So anything that happens here will eventually happen in the dev branch and vice versa. It's just that things obviously happen in the dev branch a lot quicker. And just a secret between you and me, I'm gonna start live streaming myself developing the dev branch for patrons as well. So just keep an eye out for that. But that being said, I'm gonna say that for the first half of this year, the game engine series definitely not gonna touch 3D. I mean, to be honest, I'll be surprised, maybe happy if we actually end up touching 3D this year in this kind of public branch. The reason is that we've gone down this 2D path, which you guys voted for, by the way. 51% of you picked 2D, so that's why we're doing 2D. But anyway, the point is, since we've picked 2D, I don't want to kind of turn Hazel into, oh, this is just an engine where we just jam features upon features upon features and we just kind of widen the technology base and then we optimize it and then we do all of that. That's useless to me. Hazel is a platform upon which you build applications. So what we should be doing is trying to achieve that kind of base, kind of minimum viable product, vertical slice, whatever you want to call it, that will actually allow us to fulfill the goal of Hazel, which is to create an application. That is what Hazel is for. It's a framework and it's a platform for creating like 3D interactive or 2D interactive let's just say interactive graphical applications. That's what it is for. And of course, games are included, and that's probably the primary use case for this engine. So that being said, what I want to do and my actual goal for this year is to basically take something like Flappy Bird, because that's kind of, you guys check out that video where I made a game in around an hour using the Hazel engine, and I had to actually add a bunch of stuff to it. That is a good example of what Hazel is for building something like that. So what we're going to do is we're going to work backwards. We're going to take that game, we're going to take that example, and we're going to say, okay, what do I need to do to make it the ideal scenario of building that game, of building that Flappy Bird clone inside Hazel? So in other words, if Hazel was perfect, if Hazel was finished, and I sat down to make that game in Hazel, what would that process look like? What would I do? And there's so many things that are going to come up, obviously. And I did kind of talk about this in the previous episode, I think. I talked about, well, we actually just pulled some features in that I had to write, I think, to make that Flappy Bird game even happen. Stuff like, rotation for the quads and whatever. But anyway, my point is that we need to take that and we need to kind of almost reverse engineer it. Not really reverse engineer it, but potentially even look at something like Unity and see, what is that process like? What do we like about that process? Okay, let's look at Unreal. What do we like about that process? What do we not like about that process? And then take that into Hazel and then try and create something that is hopefully a combination of everything we like, filled with probably ideas that we come up with that don't exist in any other engine. And then we'll end up with something that's actually usable, something that actually does something, instead of like, oh, hey man, like my maths is SSE and it's like super fast, but I can render a triangle and that's it. Shouldn't be drinking from this. It's not a water bottle, but I really wanted water. So to kind of outline a few of the things that I think are important to make that happen, the first of which, and the kind of the most glaring thing that I see at the moment, is the fact that whatever we at the moment write in Hazel has to be written in C++. That's not exactly ideal. The reason is that C++ is a very, like the turnaround for compiling C++ code, and also the barrier of entry, I'll say, to that is quite high. Like to get a C++ programmer to write like a little movement script for a Flappy Bird game, that's not good, because it means that to write anything, to create any kind of interactive application in Hazel, you need to know C++. That's not good. What we should do instead is use a much easier language that we'll use as a scripting language. So in other words, we'll use it to interact with Hazel's API, as well as a number of utility like classes and functions and all of that stuff. So in other words, it's kind of like just a puppeteer with puppet strings. You don't have to move the puppet itself. You can actually just attach strings to the parts of the puppet that you would like to move, and then a puppeteer can easily move that puppet. That's kind of what a scripting language is, and that's kind of the goal for this as well. Instead of having to kind of write all of the C++ code to make anything happen, we should just be able to control Hazel like a puppeteer from within some kind of scripting language. Now, there's been so much discussion about what scripting language to use. I mean, honestly, there's been so much, because there are quite a lot out there. I've kind of tweeted about this and I've said, hey, what do you guys think of this and that? The consensus, and I guess also my opinion, is that we should go with Lua. The reason is that Lua is extremely fast, it's quite simple, it's very lightweight, and it's just very popular. Lots of people know Lua. Now, there are syntactically like languages that I prefer, and who knows, maybe one day we'll write a Cherno language and everything will be the best. But at the moment, that's not happening. So at the moment, we have kind of Lua, we have maybe Python, but that's a different story. C# is another very good example. I love C#, honestly, one of my favorite languages. It's so elegant, it's so beautiful, but it's quite heavyweight. I mean, it requires like a whole virtual machine. If we use Mono, there's a lot of licensing like complexities, I'll say, with that, as well as the fact that having the entire Mono runtime and all of that stuff, I don't know, for me, I think it's a bit overkill, especially for an engine that we're not exactly commercializing. I don't want to make this a commercial engine. I want this to be a nice and simple and well-written platform upon which you can also do a lot of work upon, right? So in other words, if you wanted to use Hazel in something and you really wanted C#, maybe you could add that yourselves, but I don't think I want to go that direction, because it's just going to make it too complex. And yes, it would be good, but at the moment, based on what I know about what it takes to get C# as a scripting language for, an engine, it's a lot of work. I mean, okay, look, if this was Windows only, I want to clarify one thing. If this was Windows only, this engine, which it's not obviously, and it never will be because that's weird. But if it was Windows only, we of course could just use like C++ CLI to wrap all of our C++ code and give access to the kind of C# runtime and C# projects, you know, the ability to kind of control all of that C++ code via, I mean, you could use like other functions, but C++ CLI is probably the most sensible way to do that. That's actually something that Sparky used to use briefly, but it is quite a lot of work to wrap obviously every class in that kind of C++ CLI intermediate language, but it's possible, and that would be very straightforward, and that would be a lot simpler than having to embed an entire runtime, because essentially it would just be a C# app, a Windows Microsoft C# app that just used a C++ library, and that would be fine. But because we need it to work on multiple platforms, we really have to embed the entire C# runtime into Hazel, because how is it going to run on an iPhone? It's not. You need to actually make sure that you compile the C# runtime for like iOS and make sure that it works, and then it's basically Hazel comes with its own language kind of thing. Now with Lua, that's really simple, because Lua is like a couple of C++ files, I think, and that's like it. It's like 5,000 lines of code for the whole language. Like, it's really simple, and I think that it's going to be an excellent base for us to build upon and make Hazel good. And technically speaking, again, since that scripting language is like a puppeteer controlling absolutely everything that we do, there's nothing really that it can't do. Like, yes, some people might not like the syntax. Some people don't like the fact that it doesn't have curly brackets, or that, you know, you have to write end everywhere. But like, that's just the language. That's just the way it is. I mean, if you really wanted to, you could modify the syntax and make your own language and then have that compile to Lua, and then Lua compile to, anyway, whatever. I don't think we're going to do that. The point is that that's kind of how I see this going forward. And that's what I see as the major feature for this year for Hazel, probably scripting. Because if we add scripting, then we can actually start to kind of have a layer upon which people who might not be familiar with C++ can actually build a game, and then, you know, we can kind of underneath the hood flesh out all of these C++ features. Speaking of which, C++ features, the biggest one's going to be 2D rendering, because we need to get our rendering sorted out. Now, I did have a batch renderer series, or a batch rendering series that I did on my channel. I'll link the first episode up there. It's called Intro to Batch Rendering. That's done now, and in fact, I even wrote a batch renderer within an hour. I'll also link that up there. And so go check that out if you're interested in batch rendering, because that's what we're going to start on next week, because that's not going to take more than like a couple episodes probably. So we'll kind of get that out of the way so that we can actually properly render 2D graphics quickly inside Hazel. So that's our step one, and I promise that episode is coming next week. And you can check that out immediately. If you want a head start, check that out right now. But the problem is there is no source code. I was supposed to link the source code in the description, but just to be brutally honest with you guys, I deleted it. I have this thing that I do sometimes where I just delete code. Like, I've done that at EA. I deleted 1 month's worth of work that I had worked on at EA accidentally. I don't know how. Like, literally, I lost the code. So that's what happened this time as well. It was completely my fault though. This time, I still maintain that something weird happened with that kind of EA example, and I don't even know what happened, but I just lost it. Honestly, I didn't know where the code went. I was like, why is it not here? It's gone. But with the 1 hour batch renderer, I had it like in version control. I had it on Git, and I kind of, every episode of the batch rendering series, I committed the code for that episode just so I could roll back if I needed to and I could see everything. But because the batch renderer series happened within like, well, the 1 hour batch renderer happened after the vertex buffer episode, but before the index buffer episode. What I did was I wrote all of the batch renderer, the 1 hour batch renderer, on top of the vertex buffer episode, and then, like the next day, I needed to record the index buffer episode, so I rolled back the code without actually committing that. So in other words, I just discarded all of my local changes, and they vanished. And then like an hour later, I was like, oh, that is a shame. And I was like, guess I better sit down and write that code again, but I never did, because who wants to write that entire code base again? I'd have to literally watch the video that I made, the 1 hour video that I made, and then kind of write down all of the code. So I'm sorry, it's gone, but we're going to integrate into Hazel next week. So that is the current plan. Now, I did promise we would dive into some code. What are we at? 20 minutes. Man, time flies. I'm gonna have to like check my curry in a minute. I think that the primary thing that I kind of wanted to check out was, yeah, this kind of renderer 2D that we had. I mean, we have renderer 2D storage. We have a struct called renderer 2D storage, and then we have like a static pointer data. I don't know. I thought this was actually worse than it was, but it's honestly not that bad. The point is, if we just jump over here, I'll show you guys where we're at right now. This is what Hazel looks like at the beginning of 2020. We have this kind of, that's some pretty nice smooth scrolling, by the way. Anyway, so we have these kind of two squares or two rectangles being rendered. This is currently done using this renderer 2D class, which has a whole bunch of functions that are needed for this. However, you can see that every time we draw a quad, we bind our kind of texture shaders, or like we bind the texture shader and then bind the appropriate texture. We calculate a transform, we bind the vertex array, and then we actually draw it. So in other words, we have this kind of one draw call per quad mentality, which is not good. It's garbage, in fact, and we don't want to do that, and that's why I just fell off the table. Anyway, that's why this whole batch rendering series has existed, and that's what we're going to do here, because this limits us to probably drawing a couple thousand quads, and that's about it realistically, unless you've got a very beefy computer that can handle like 8,000 draw calls or whatever. But what we want to do is we want to be able to draw tens of thousands, if not hundreds of thousands of quads, and that's what batch rendering is going to let us do. So we're going to kind of take this entire renderer 2D class that we have here, and we're going to convert it into a batch renderer. So this will be the purpose of this, and this is really important. There has to be an easy path for Hazel at all times, right? The complexity of the code inside Sandbox 2D, right? So I'm talking about all of this stuff, right? I mean, right now it's even more complex than it really needs to be. But my point is that the code that we write in here, the code that the client has to write, that the user who is using Hazel to build something has to write, that has to be dead simple, right? It has to just be really simple. It has to work. That can't be like a batch renderer 2D begin batch. Like, what does that even mean? No one cares. I want to draw a square, you know? That's the kind of mentality that I really strongly believe in, because if you're making your user do a lot of stuff, then that's a bit odd, because in so many scenarios, if you just have a little reality check and you have a look at someone who's using your engine and how they're using it, if they want to draw a textured quad on the screen, it should not be 100 lines of code. It should not be 5 lines of code. It should be draw textured quad. Done. I mean, obviously there's some information that needs to exist, such as like, you know, the texture and where the quad is on the screen, and, you know, maybe there's a camera or a scene that's being used and is added to. But my point is that you can't just have all of this code in order to make something as simple as that happen. And so that's what we're gonna kind of do. We're gonna probably not change the API that we have here too much, and we're definitely not gonna do any kind of like begin end batch stuff. That's weird. We're just gonna write this code in a very simple way. In fact, what you see here inside on update is very likely going to stay the same, especially this section here, right? I like the way this API looks. We begin a scene, right, which at the moment, you know, takes in a camera. In the future, we'll probably take in a scene object, right? And then we'll do this kind of draw rotated quad or draw quad or whatever, and then we'll do end scene. Now, this obviously applies to a version of Hazel, or rather let's just say a branch of Hazel, not like a literal like Git branch, but just like this refers to Hazel being used in a way where you want to control the rendering yourself, which I want to allow as well, right? Because realistically speaking, if you look at Unity, or any other engine, you're not telling it, hey, render a 2D, draw me a quad. No, you add like an object to the scene, and then like, you know, you give it like a sprite, or you give it some kind of appearance. And then, you know, the scene will tell the renderer, hey, I need you to render something on the screen, right? That's how it works. So obviously, like ideally the client wouldn't even be interacting with the renderer, right? We kind of give all the information into the scene and we make it happen. And that's actually something I'm working at the moment on in Hazel Dev, for like 3D scenes and everything. But in this case, we're gonna flesh out this renderer 2D first, and then we're probably gonna talk about like scenes and maybe like game objects or like entities, and kind of you know, do all of that, because that's going to be the natural progression to like that Flappy Bird game, where at the end of it we should have like maybe an entity component system, a like serialization system, I expect, maybe like a UI system, a scripting like runtime, all of this stuff, and scenes and everything, where we can just kind of add like a, you know, game character object to or whatever, and we can kind of set up the game so that it actually works like a real game instead of having to do everything manually here. So that is the plan for this year. Hope you guys enjoyed this video. If you did, please hit that like button. Patreon.com/thecherno, best way to support this series. If you're excited for this year, or as excited for this year as I am, then write a comment telling me you're excited, or help support me, because that's how this is gonna happen. So, and I will see you next time. Goodbye.